Hi guys, so today we're going to look at our last conic section. Today we're going to look at hyperbolas. So the process to graph a hyperbola is going to be very similar to start with how we did ellipses. There's just going to be a little bit of a change at the end. So a hyperbola is kind of similar to an ellipse. It's a set of all points where, except this time, the difference of the distances from any point in the hyperbola to two fixed points, still called foci, is constant. So the difference here for an ellipse, it was where the sum was the same. For a hyperbola, it's difference. So again, there's another link on Schoology that kind of shows you visually what this actually means. But what it's going to create, hyperbolas are going to look like kind of two parabolas. So you could have them like this, or you could have them like this, and that's what our hyperbolas are going to look like. So the way these work is if you slice that cone perpendicular to the base. So basically, if you go through both cones, so you've got a cone up here at the top, you've got a cone here at the bottom, and you take that thing and you cut through both of those cones right there, that's how you're going to create that hyperbola. All right, so there are your two equations. You're going to notice these look very similar to the way those ellipse equations do. There's just a couple differences here. One difference, the big difference, there's a minus instead of a plus. All right, there's a minus instead of a plus. The other difference is in both equations, the A is the thing that comes first. Now, the reason with that, what's going to make a difference here, with an ellipse, it mattered which number was bigger. But for a hyperbola, what's going to matter is which letter comes first. Does the x come before the minus, or does the y come before the minus? Now, when you're adding, it doesn't matter what order you add in, but subtracting order does matter. Okay, 8 minus 2 is different than 2 minus 8. So which one comes first is going to depend on which direction this is going to open. Which one's the bigger number will change the way the graph looks, but it won't have an effect on if it's horizontal or vertical. So just like it's been for all the others, HK is the center. Again, it doesn't matter if A or B is bigger, it matters which letter comes first. So if the x comes before the minus, then the hyperbola opens left and right. If the y comes before the minus, then the hyperbola opens up and down. Again, C is going to be how far you move from the center to find the foci. That is the same, but what's different, though, is your equation. This one actually looks like Pythagorean theorem. It's a squared plus b squared. So that is also a little bit of a difference from ellipses. If the hyperbola is horizontal, just like for an ellipse, you're going to move left and right to graph the foci. If the hyperbola is vertical, you're going to move up and down to graph the foci. There are two types of axes that you'll talk about for a hyperbola. They're not called major and minor, though. They're called transverse and conjugate. And that should be a J, not a G. Sorry about that. So the transverse axis is the one that actually touches the points on the hyperbola. So if you have a hyperbola that goes this way, that's the transverse axis. The conjugate axis will go through there and not actually touch it. If your hyperbola opens left and right, the transverse axis is the one that touches, which is horizontal, and the conjugate axis is the one that doesn't touch. So the way we're going to graph a hyperbola, we're going to start the exact same way you'd plot an ellipse. Okay, we're going to plot the same points the same way. The only difference is for an ellipse, we made kind of those 4 points, and then we drew our ellipse. What we're going to do for hyperbola is we're going to make those 4 points, but we're going to make a little dotted line box that goes through those 4 points. Then what we're going to do is we're going to draw an X through the center and the corners of the box, like that. And what that's creating are the asymptotes for these parabolas. So then once you have that done, and those are the asymptotes, once you have that done, you just draw the curves of your hyperbola. So if the X comes first, you'll draw them on the sides. If the Y comes first, you'll draw them on the top and the bottom. So we're going to draw the curves, like I said, either left and right or up and down. They're going to go between the asymptotes, and they're going to go through the vertices. And those vertices are those points that we'd plot to get that box there. So we'll do a couple examples, and then we'll kind of try to write some equations. So again, the very beginning steps here are going to be no different than what we did for an ellipse. Okay, finding the center, that's the same thing. Okay, look at your X, opposite sign. Look at your Y, opposite sign. Direction, again, it matters which one comes first. X comes first, so this is horizontal. How far left and right? We'll look under the x and square root it. How far up and down? Look under the y and square root it. So negative 3, 1 is our center. So I'm going to go left 4 and right 4. I'm going to go up 3 and I'm going to go down 3. And that's exactly the same thing that I did for an ellipse. The only difference here, this is not an ellipse, there's a minus. So I'm not going to just connect my dots. What I'm going to do is I'm going to make a little dotted line box that goes through those points. Then we're going to make an X that goes through our box. So what I'm drawing here in pink are the asymptotes for my graph. So the last thing we do is we actually draw the graph. So since X comes first, we're going to draw this left and right. So just in between the asymptotes and through that vertice. In between the asymptotes and through that vertice. And there's my graph. So the actual graph is only the purple parts, but all these other little features help us to actually draw it. All right, let's find our foci. So we need our c value. So for this one, c squared is a squared plus b squared. So c squared is 16 plus 9, which is 25. So c is 5. And then we find the foci the same way we did for an ellipse. It's horizontal, so we'll move left and right. So from the center, we'll move left and right. Now you can actually graph this and count 5, or we can do it the same way. If we're moving left and right, we're going to change the x-coordinate of the center. So negative 3 minus 5 and negative 3 plus 5. And the y's don't change. Again, if you wanted to graph this one from your center, just move 1, 2, 3, 4, 5. There's a foci, or there's a focus. And there's your other focus. It's good to kind of know the algebra part that was, again, when there's square roots, we got to be able to write it. So if we're moving left and right, we change the x-coordinate of the center. If we're moving up and down, we change the y-coordinate of the center. All right, the transverse axis, remember, is the one that actually touches the graph. So the transverse axis would be this one that I'm making right here in blue. The conjugate axis would be this one right here that I just made in green. So this is asking for blue. Okay, so in blue, the transverse axis, that total length, is 8. The vertices are the ones that are on the transverse axis that actually touch those. So the coordinates there would be negative 7, 1 and 1, 1. Domain is actually a little tricky to write on this one. So remember, for domain, we read left to right. The farthest left this graph goes is negative infinity. Then we go until negative 7. It does actually touch that point, so we use a bracket. Then there's a big gap, so we're going to use a U. Then it picks back up at 1. It actually touches that point, so we use a bracket. And then it keeps going to infinity. Range this way is a little bit easier. Our range is negative infinity to infinity. All right, let's try another one. So again, we're going to start by kind of plotting the points the same way we would for an ellipse, but we need to be careful because, again, the order here matters. Look for your x's to write your x-coordinate of the center. It's x plus 1, so negative 1 is the x-coordinate, negative 3 is the y-coordinate. So negative 1, negative 3 is my center. Y comes first, so this is going to be vertical. It's going to open up and down. Under the x is 25, so I'm going to go left and right 5. So I'll go ahead and mark those points. Under the y is 4, so I'm going to go up and down 2. So now let's draw our box. Let's draw our x. And then let's actually draw our graph. Since the y came first, this one's going to be up and down. So we're going to be at the top part and the bottom part. And there's my hyperbola. All right, let's find our foci. C squared is equal to a squared plus b squared. So c squared is 29. So c is the square root of 29. Since we went up and down for our graph, we're going to go up and down for our foci. If we go up and down, that's going to change the y-coordinate of the center. So take the y-coordinate plus and minus the c value. Transverse axis is the one that actually touches it, which would be, in this case, the vertical one. So that length is 4. The vertices are the two that are above that point. So we've got negative 1, and -1, -5. Domain is negative infinity this time. Our range, we start at the bottom. -infinity until the y value of -5 with a bracket, union, bracket, -1, and we keep going to infinity. All right, so now we're going to go ahead and write some equations. All right, so it gives us some information. So again, a lot of times when you see this information, it helps to kind of draw a picture. It makes it a little bit easier. So it tells us where the foci are. -1, 2, and 5, 2. Well, if our foci are there, okay, let's go ahead and also do our vertices. Our vertices are at 0, 2, and 4, 2. All right, so this gives us a lot of information. It tells us, first of all, this is going to open left and right, okay, because of where our vertices and our foci are. We also can find the center because the center is going to be in the middle of all those things. So in the middle of those, right there, that's going to give us a center of 2, 2. Because that's going to be that halfway point between both the foci and the vertices as well. It's halfway between all of them. Since it's going to open left and right, the x is going to come first. So x minus 2 squared, y minus 2 squared. All right, then we'll go ahead and do our bottom stuff here. So let's figure out how far we're moving to the side. Well, to go side to side here, I'm moving 2, so 2 squared is 4. I don't know how far I'm moving up and down, though. But what I do know is that a squared plus b squared is c squared. And it doesn't matter which one's A and which one's B, okay? It doesn't matter which one's bigger because we're adding them. So 4 plus b squared is going to give us c squared. Well, I can figure out what c is. Okay, c is going to be the distance from the center to the focus. That's a distance of 3, so c squared is 9. So b squared is 5. So underneath here would be 5. So that means if I were to actually graph this entire thing, I'd have to go up and down the square root of 5, which would be kind of ugly, but at least we can write the equation. All right, let's try to rewrite. We're going to go ahead and rewrite this in standard form, just like we did with ellipses. So in order to do that, remember, this has to equal 1. So we're going to divide everything by 16. Then I can reduce those fractions, and it's in standard form. Well, now what it says to do is to write the equations of the asymptotes. So the asymptotes we drew in our graph. And if you want to graph this and just write the equation off the graph, you are welcome to do that. That's one way to do it. You also can use these equations, though, to help you actually write those equations. So if this is vertical or horizontal, there's one thing that's going to change, and that is this b over a and a over b. What matters is that whenever we're going to square root both of those numbers, okay? The square root of both of those numbers are going to be the two things that go here. The thing to keep in mind, slope is rise over run. So whichever one is the y needs to be at the top. Okay, so if it's under the y, it needs to be at the top when we find the slope. So let's go ahead and write this. This one is horizontal because x comes first. So y equals k. Well, k in this case is 0 because it's not y plus or minus anything. B over a. So again, b in this case is the second one. It's the y. So square root it. So that would be 4 over 2, which is just 2. And then x minus h, well, h is 0 because there's nothing added or subtracted here. So plus or minus 2x. All right, so we're going to find the equation of the asymptotes again, but this time we're going to have to complete the square. Now again, like I said, this is the hardest algebra you guys are going to do by far, and it is really good practice, though, the more you do it. So I'm going to start by rewriting it to put my x's together and to put my y's together. Well, there's only one y, so this one actually isn't that bad. And move the number to the other side. There's a number in front of my x, so I need to factor it out. And then I leave my blank. To figure out the number that goes in the blank, take the b value, divide it by 2, and square it. I almost wrote 2, it's 1. But again, I didn't actually add 1 to this equation. I added 1 times 4. So what I really need to add over here is 4. So that becomes x plus 1 squared minus 9y squared. I lost my squared there. And that's going to equal negative 36. Now this whole thing is supposed to equal 1. So we have to divide everything, just like we did in the last one, by negative 36. Now we can reduce the fractions. And if I have a negative divided by negative, that becomes plus. So what I'm probably going to want to do is rewrite this in the order I'm used to seeing it. The one that's positive should come first, and the one that's minus should come second. Now let's write those equations of the asymptotes. So this one is vertical. The y comes first. So it's going to be y equals k, which in this case, again, it's 0. There's nothing that we're adding or subtracting to this y value. Plus or minus, and then in this case, it's a over b. And just remember, it's the y over the x when you square root them. So that would be 2/3. And then it's x minus h. And those are the equations of your asymptotes. All right, so the last thing we're going to do, now that we have looked at all of the conics, we are just going to determine what kind of conic we have without completing the square. Because as you guys have seen, that takes a lot of time. So there's actually a faster way to be able to figure out what we have if we don't see that equation pretty quickly. So if we see what's called kind of this general form, where it's kind of all written together, it doesn't look like that nice, easy to graph form. The first thing we're going to do to kind of separate these conics from each other is to figure out, are both variables being squared? All right, if both variables are not squared, then it's a parabola. So if you look at these examples here, if you look at number 3, there's only an x squared, there is not a y squared. So that's a parabola. And there's another parabola as well if you look at number 6, because that has a y squared and it does not have an x squared. So if you don't see both x squared and y squared, it's a parabola. So now all the rest of them have both an x squared and a y squared. Well, now what we see is, do they have a different sign, plus minus? Is one positive and one negative? So let's look at our examples here. Well, number 1, the x squared is positive, the y squared is negative. That means that's a hyperbola. All right, then let's look at, there's one more, number 4. They both have a 5, but one's positive and one's negative. So that's also a hyperbola. And then the last thing we can do at this point they both have squareds. They're both the same sign. They're either both plus or they're both minus. Well, now we need to see, is it the exact same coefficient? So if you look at number 2, one's a 4 and one's a 9. So that's an ellipse. But if you look at 5, they're the same number. So it's a circle. All right, so that is it for conics, guys. We are almost done with everything. These are our last conic sections. We're going to look at one last new type of graphing in our last unit this year.